In this practice, find the solution of the following partial differential equations. Second partial derivative of u with respect to x minus first partial derivative of u with respect to y equals 0. We use a separation of variable method. U is a function of x and y is expressed. The product of the function of the capital X is a function of lowercase of the x. Capital Y is a function of y alone. Then we substitute into the differential equation. Second derivative of u with respect to x is expressed x2 prime y. And round u, round y is expressed xy primes. So x2 prime is a second derivative of x with respect to x. The y prime is a first derivative of capital Y with respect to y. The equation becomes x2 prime y minus xy prime equals 0. From these equations, you can find x2 prime over x equal y prime over y. The left hand side is a function of the x alone. The right hand side is a function of the y alone. To satisfy this equation, it has to be the constant values. As a constant values, we write a minus lambdas. So equations becomes the x2 prime plus lambda x equals 0 and y prime plus lambda y equals 0. Two equations. So we consider the three cases. First case is lambda equals 0. So this means x2 prime equals 0. As a solution of the capital X is a c sub 1 plus c sub 2 x. From the y prime equals 0. Y is a constant value of the c sub 3. And u is a product of the two functions x and y. So it becomes c sub 1 plus c sub 2x times c sub 3. As a solutions, you can write a sub 1 plus b sub 1x. So this is a solution when the lambda equals 0. In the second case, lambda is a negative quantity, so negative alpha squares. The equation becomes x2 prime minus alpha squares x equals 0. And y prime minus alpha square capital Y equals 0. From the first equations, x is expressed c sub 4 hyperbolic cosine alpha x plus c sub 5 hyperbolic sine alpha x. From the second equations, you can find capital Y is a c sub 6 exponential alpha square y. Then u is a product of the capital X, capital Y. Then it becomes exponential alpha square y. A sub 2 hyperbolic cosine alpha x plus b sub 2 hyperbolic sine alpha x. This is the solutions when the lambda is a negative quantities. In the last case, lambda is a positive quantities. Then plus alpha square x equals 0. The y prime plus alpha square y equals 0. So from the first equations, x is expressed c sub 7 cosine alpha x plus c sub 8 sine alpha x. For the y is a c sub 9 exponential minus alpha square y. Then we combine these two expressions to find the u. It's a product of the x and y. Is exponential minus alpha square y times a sub 3 cosine alpha x plus b sub 3 sine alpha x. This is a solution when the lambda is a positive quantities. I showed how to solve the partial differential equations. Depending on the value of the lambdas, we have three types of solutions. This is the answer to this practice.